And as anyone who's ever blown across the top of a bottle to play a note knows, you can also form a stationary sound wave in a pipe that is open at one end and closed at the other. Now again, the open end needs to have an antinode there, but the closed end needs to have a node. So these are the first three patterns that you get. And turning them on their side, we can see that this time we've got only a quarter of a wavelength in this one. And then here we've got 1, 2, 3 quarters, and here 1, 2, 3, 4, 5 quarters. So this time the rule is that you will get a stationary wave in the pipe if the length of the pipe is an odd number of quarter wavelengths. Now you can write that as a formula like this, however there's no need. You can, if it was me, I would just keep writing this. The length of the pipe needs to be equal to an odd number of quarter wavelengths. We can use this setup to find the speed of sound in air. And so this is how we do it. We have a pipe here that is actually open at both ends, but we've lowered it into water, and so the water is forming a closed end at the bottom. So open here, closed end there, and so that's forming a pipe of length L. But obviously by moving the pipe in and out the water, I can change the length of L there. Okay, so we're going to start with the pipe completely in the water, so L wants to be like as small as you can get it there really, so ideally 0, but as small as you can get it, and then you're going to lift it out and L is going to get bigger and bigger. And you're going to play a note of known frequency into the top of the tube. Now the frequency of the sound decides the wavelength of the sound wave. So when this length reaches a quarter of a wavelength, we're going to get a standing wave, and that means that the sound waves are adding up. They're bouncing backwards and forwards in here, but they're always adding up, and that's going to give a really loud sound. Before that, when L is not the right length to get a standing wave, the sound waves, they're overlapping still, they're superposing still, but they're not adding up nicely, they're cancelling out a lot of the time, and so instead you're only going to have a quiet sound. So you are going to start in this situation, lift it out, and you're going to hear a noise, but it's just going to be quiet. And then when it'll suddenly, it's really impressive, this is practical, it'll suddenly go really loud, and that's when the length has reached a quarter of a wavelength. And then you stop, measure what that length is, and then that length is a quarter of the wavelength, so the wavelength is 4 times the length, and so you can calculate the speed of sound.